Video number 4. These are the calculator problems. Notice you have 45 minutes calculator problems. You have 45 minutes and there's 31 questions. I'm going to try to do these in 2 batches. I have my calculator here. Okay, so here's the questions, calculator questions, and they give us some information. There's the first question. Tyra just subscribes to an online gaming service. Monthly fee is $5 and it's 25 cents an hour for time spent playing premium games. Which of the following functions gives Tyra's cost in dollars for a month where she spends X hours playing premium games? If you know how to put together equations, this isn't a hard problem. Suppose we don't know how to do that. I'm just going to let, for number 1, I'm going to let X equal to 100. I played 100 hours, and so now if you look at the choices, here's the choices. X is 100. So what is the cost for choices A, B, C, and D? Okay, so for choice A, I would get 525 times 100, which is $525, right? Because you just moved that way. For choice B, we would get 5 times 100 plus 25 cents. Well, that's going to be $500 and 25 cents. For choice C, we're going to have 5 plus 25 times 100, and that's 25 cents times 100, which is $5 plus $25, which is $30. And for choice D, we're going to have 5 plus 25 times 100, which is now $25 times 100, which is $2,505. Well, even if you know nothing about algebra, what do you think is the reasonable price? How much are you going to pay a month for this? No one's going to pay $500 or even $2,500. This has to be the right answer. But how do we know it's the right answer? Well, we know that we pay $5 a month and then plus 25 cents per hour, 25 cents per hour, 25 cents per hour, and we played 100 hours. So that's 5 plus 25, and so that's 525. 525. Okay. 5 plus 25. I can't even look at my multiplication there. 5 plus 25, which is 30. Okay. So yeah, the choices are supposed to be reasonable. Number 2. The grocery store sells, we're looking at the problem here. Grocery store sells a brand of juice in individual bottles, packs of 6 bottles on a certain day. They sold a total of 281 bottles, of which 29 were sold as individuals. Which equation shows the number of packs of bottles sold in a day? Okay, so once again, I can do the algebra. Here I'm going to do arithmetic. Let's suppose P is how many packs of bottles do you think they sold? I don't know, just pick a number. Let's say they sold 10. If they sold 10, then let's see. We know we had 281 total, 281, but 29 were individuals. So let's go to our calculator here. We had 281, take away the 29, so that means 252 were sold in packs because these are individuals. Okay, and what's the number of packs sold that day? I guess we got to divide this by 6. I'm not sure why I let P equal to 10. We can try that. Let me just go through here. 252 divided by 6. Okay, so we get 42 is the right answer. Which one of these gives me 42? So now you can just check. Here's choice A. Choice A is 281 minus 29 divided by 6. Okay, so that's 42. That's right. If we look at choice B, That's 281 plus 29 divided by 6. Well, that's not 42. That's wrong. Choice C says we have 281 divided by 6, and then we're supposed to subtract off 29. That's not 42. And then the choice D is 281 divided by 6, and then we're supposed to add 29, and that's not 42 either. Oops. That is not 42. 289. Let me take away some of that stuff. 281 divided by 6. There we are. And then add 29. Okay, that's not 42. The correct answer is A. Okay, number 3. Monthly rainfall in Chestnut City. The line graph above shows monthly rainfall from March to October last year in Chestnut City, which, according to the graph, what was the greatest change in the monthly rainfall between 2 consecutive months? So if you look at the picture, how much did it change between March and April? It looks like it changed about 1/2 inch. And then from April to May, it changed from 3.5 up to 4.5. So that's a full inch, and then another 1/2 inch down. From June to July, it went up, let's see, from 4 to 5.5. So that's 1.5 inches. The biggest drop and the biggest change is way over here between September and October. We went from 5 all the way down to 2.5. So hopefully you could look at that, and that would be choice C, 2 consecutive months, September to October, choice C, 2.5. Okay. Problem 4. A rectangle has perimeter P, length L with W. Which of the following represents L in terms of P and W? Okay, so this one we can do the algebra, or we can create some numbers. We have a rectangle and P, and we have L, and we have W. So we're just going to pick up some numbers. Let's suppose the L is 4 and the width is 2. What would the perimeter be? Hopefully you know perimeter means the distance around. So 4 plus 2 plus 4 plus 2. So the perimeter has to be 12. Okay, so we've got L is 4 and W is 2. One of these choices, here's choice A. Choice A says L is the same as, this is choice A, not equals. L is the same as P minus W. Does that work for our problem? L is 4 is the same as P, 12 minus W? No. 4 is not the same as 10. Here's choice B. Choice B says L is the same as 2P minus W over 2. Okay, now for our problem, again, we said the perimeter was 12 and the length was 4, so we have 4 is supposed to be 2 times 12 minus 2 over 2. 4 is supposed to be the same as 24. Take away 2 over 2. 4 is the same as 22 over 2. No. So we've lost choice A and choice B. Let's try choice C. By the way, notice I'm not really using the calculator on this, even though it's permitted. Choice C. We have length is equal to P minus 2W over 2. So for our problem, 4 is supposed to be the same as 12 minus 2 times 2 over 2. 4 is supposed to be the same as 12 minus 4 over 2. 4 is supposed to be the same as 8 over 2. Yep, that's the right answer. So choice C is it. And just to double check to make sure, here's choice D. Choice D says length is the same as 2P minus 2W. For our numbers, 4 is supposed to be the same as 2 times 12 minus 2 times 2. And obviously that's not true. 24, take away 4. 4 is not equal to 20. Okay, so that's out. The choice is C. Now, notice I didn't do any algebra here. If you're looking at just from an algebra perspective, because, I suppose having had algebra, you should be able to write down the equation. The perimeter of this rectangle, if this is length and this is W, is going to be 2 length plus 2W. And trying to solve that for L, if we had to solve this algebraically, we get P take away 2W is 2L, and then divide by 2. And so we get L is P minus 2W over 2. And that is choice C. If you're good on algebra, just do it with algebra. If you don't want to do algebra, you don't have to. You can just pick numbers for L and W and work it that way. Okay, number 5. Which ordered pair satisfies the system of equations? 2x minus 2y is 6. Oops, 2x minus y is 6. And x plus 2y is negative 2. The x and the y have to work in both of these, and we'll just go down the road. We're not going to try to solve the system of equations. We could, but let's just try the choices. Negative 6, 2. Does that work in this equation? Let's see. 2 times negative 6 minus 2, does that equal 6? And if you see this is negative 12, take away 2, that does not equal 6, so choice A is out. Okay, let's try choice B. Okay, so choice B, we've got negative 2, 2. And again, we're going to check to see whether it works in the first equation. And by the way, it has to work in both. But in the first equation, we have 2 times negative 2, take away 2, and that's supposed to be 6. Well, that doesn't work either. That's negative 4, take away 2. That's not 6. All right, that's negative 6. So choice B is out. And so we go down to choice C. Choice C. Sorry, erased my problem there. Choice C. Okay. In choice C, we've got, this is choice C, we've got 2 and negative 2. We'll put that in here. Again, so 2 times 2. Take away a negative 2. That does equal 6. That's 4 plus 2 is 6. So that's good. But let's make sure it works in the second one as well, because it's got to work in both. So in the second equation, we've got 2 plus 2 times negative 2. Does that equal negative 2? 2 minus 4 does equal negative 2. Yep, so it works in both equations. The answer is C. Now, I suppose, you know, your algebra teacher, if you had Algebra 2 or if you're in Algebra 2 now, would want you to solve this algebraically. But notice in the PSAT, you do not have to do it algebraically. You can do it with just arithmetic. Here's the algebra for all you algebra students. What I would probably do is multiply this top equation by 2, both sides, multiply by 2, and that gives me a new equation. I'll write it down here. So I have 4x minus 2y is equal to 12. And this one I'll leave alone. This is x plus 2y is equal to negative 2. I add them up, and I get 5 x's are equal to 10. So x has got to equal 2. Now notice choice C is the only one that has x is equal to 2. So it has to be choice C. We don't even have to chase down and find what y is. Okay, number 6. Number 6, a soda company is filling bottles from a tank. Tank has 500 gallons, 500 gallons of soda in it. At most, how many 20-ounce bottles can be filled from the tank? And we have 1 gallon is 128 ounces. Okay, so we're going to try to fill these 20-ounce bottles. The first thing we might want to do is figure out how many ounces are in here. 500 gallons, we'll go to our calculator for that. 500 gallons times 128, so that's 64,000 gallons, or 64,000 ounces. This 500 gallons is the same as 64,000 ounces. And we're filling these 20-ounce bottles. So just go ahead and divide 6,400 divided by, and that would be 20. Okay, and we get 3,200. That's the answer. Okay, number 7. A car traveled at an average speed of 80 miles per hour. Where in the world are they doing that? Probably nowhere legal. You might be able to do that in Nevada. I don't know. 80 miles per hour for 3 hours. A good old Mr. Dunn, that would tell you you've traveled 240 miles. Right? Okay, so 3 hours times 80 miles per hour, 240 miles, and consumed fuel at a rate of 34 miles per gallon. How many gallons of fuel did they use? Okay, and we have 2, 3, 6, and 7. Well, if you take the 240 and divide it by the 34, that gives you 7.05. It says approximately how many gallons. It's about 7 gallons of fuel. I suppose you could do this working backwards. If you're getting 34 miles per gallon and you multiply by 2 gallons, how far will you go? Well, that's only 68 miles. You're not going to travel that distance. Okay, so if you just try putting the answers in here, the one that's reasonable is 7. So if you multiply 34 miles per gallon times 7 gallons, 7 times 34, 7 times 34 does give you something close to 240 miles. And again, this one doesn't seem really reasonable. I don't know of any car in the world that will get 34 miles per the gallon when you're traveling that fast. The wind resistance is way too high. Number 8, what's the slope of a line? This sounds like algebra. XY plane. It passes through the point negative 5.2 and 1. That's approximately here. Here's 1, here's negative 2. And a negative 1/2 and 4, which is right about here. Okay, so this is negative 1/2 comma 4, and this one is negative 5/2 comma 1. And here's our line going through those 2 points. Now, right off the bat, you should know that lines that go this way have positive slope, and lines that go this way have negative slope. Okay, so right off the bat, you can eliminate choices A and B. The answer has to be C or D. We have to figure out the rise over the run for this particular pair of numbers. Okay, how much does it go up and how much does it go over? Okay, a quick sketch. I didn't do a real accurate sketch here, but a quick sketch shows that the slope is not 1-to-1. A 1-to-1 would be a 45-degree line where this is 1 and this is 1. This one does seem to go up quite a bit more than it goes over. So the rise is more than the run. It looks like the choice has to be choice D, even without any calculations. It's not a bad idea to do the calculations. If I was comfortable with my sketch, I would choose choice D and just move on. Here's the slope formula. You change the y coordinates and you change the x coordinates. This is the rise. This is the run. Okay, by change of y, we mean subtract the y's. 4, take away 1. Don't need my calculator for that. That's 3. To subtract the x's, it's going to be minus 1/2, take away a minus 5/2. And maybe we could use a calculator on that. I would hope not, but minus 1/2, take away a minus 5/2 is the same as 2.5, right? 5/2 is 2.5, 2.5. And notice that works out to be 2. Okay, so the answer is 3/2, choice D as in dog. Number 9, dimensions of envelopes. Scatter plot above shows the widths and the heights of 12 types of rectangular envelopes. What is the width in inches? Notice the width is running this way, and this is the height. What is the width in inches of the envelope represented by data point that is furthest from the line of best fit, and the line of best fit is not shown? Okay, so we have these points, and I'm not going to try to be super accurate here, but notice that there is this one guy way off to the side. The line of best fit would be the line that sort of approximates the trend the best. This is the line of best fit, and this is called an outlier. When you study statistics, you'll learn about outliers. This is the one they're talking about. It's furthest away from this line of best fit. So now you look at the picture, and it says, what is the width of this guy? So just go down, and the width is 7. Okay? Number 10. High school basketball team won exactly 65%. 65%. This is the wins, and this is the total. fractional games. Now, that doesn't mean they played 100 games and they won 65. The ratio of wins to total was 65 to 100. Which of the following could be the total number of games the team played? So they're giving us possible numbers down here for the total number of games. So we have 65 over 100 is some number divided by 22. Well, let's take our calculator. We'll do this. I'm going to cross multiply here. So when I say cross multiply with the proportion, I mean 65 times 22, and then going the other way, I have 100 times x. So 65 times 22 is that. Can I divide that by 100? Divided by 100, that means we should have, we can't do that. You can't win 14.3 games. So 14.3 would be the number, but you can't win a fractional game. 22 is out. Okay, so we'll take 22 away. We'll try the next choice, which is 20. Okay, so 65 times 20 now, and then we're going to divide by 100. So 65 times 20 is 1,300 divided by 100, and sure enough, we win 13 games. Okay, so that works. The choice is B. B is 20. Again, we don't have to do it anymore. We have the right answer. If we tried putting 18 in here, you would see 18 will not work. Just to sort of show this technique, if this were 18 as the total number of games, cross multiplying gives you 65 times 18, and that's that. If you divide that by 100, obviously 11.7, can't have that. And the last possibility was 14, so 65 times 14 is that number, and if you divide that by 100, again, 9.1, can't have that. Choice C, what do we say? Choice B was the answer, 20. Okay, number 11. A coffee shop is running a promotion where a number of free coffee samples are given away each day. The equation above can be used to model the number of free samples. So why? This is the free ones they're giving away, number of free samples that remain to be given away, free samples that remain to be given away after X days after the promotion. So let's just put X is the days after promotion begins. Now you don't have to write all this down. I'm just trying to get my head around the problem. I haven't seen this one yet. So how would I do this? Okay, so we have 110x plus y is equal to 1210. Okay. What does it mean that 11, 0 is a solution? Well, 11 would be x and 0 would be y. So let's try to put those in the context of what they've told us. 11 is the number of days, right, after the promotion begins, and y is the number of free samples that remain. We don't have anything left. So sad. Put a sad face there. Okay? So it looks like what that means is 11 days, we've run out of free samples. So let's see. Choice A, during the promotion, 11 samples are given away each day. That's not a very good promotion. It takes 11 days during the promotion to see 1,210 customers. Well, assuming everybody that comes in gets a free sample, right? I would think choice B makes sense. It takes 11 days during the promotion until none of the samples are remaining. That's sort of the same idea. And there are 11 samples available. Well, that's silly. So it's got to be either B or C. Now, what's wrong with B? It says you see 1,210 customers. That would work if every customer got a free sample. But a lot of people don't like coffee. So just because you have 1,210 210 customers, that doesn't mean you give away that number of samples. The answer is C. It takes 11 days during the promotion until none of the samples are remaining. Okay, number 12, another scatter plot problem. Here's the envelope. Here's number 12. Which scatter plot shows a negative association that is not linear? Well, remember what we said in the other problem. This is positive slope. That would be linear. This is negative slope, linear. Now, you can also have associations that are negative and not linear. So this would be one that's going down, not linear, still negative, but not linear. And this would be one that's positive, but not linear. Linear means obviously like a line. Okay, so let's look at the pictures. Here's the pictures. We want one that's going down. A is certainly going down. B is going down. C sort of looks like a happy face, and D is just all over the place. The one that is going down is choice A, but that is linear, and we want the one that's going down that's not linear. That would be choice B. So this idea, this is going down and not linear. These types of scatter plots or data analysis are common in statistics. We haven't seen a lot of that in high school Algebra 1 and Algebra 2. But they're going to ask it to you on Wednesday. Number 13, the histogram above shows the distribution of the height in meters of 26 pyramids. Which of the following could be the median height of the 26 pyramids represented in the histogram? Okay, so this is a word that you're supposed to know, median. Median, that means the middle height. The middle height when they're all listed in order. So if we look at the chart, we have between 15 and 30, there are 2 pyramids there. Between 30 and 45, there are 3 pyramids. I'll put 3 like that. Between 45 and 60, it looks like there's 12. I got to throw 12 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Between 60 and 75, there's only 4. 1, 2, 3, 4. And between 75 and 90, there's only 1. Poor guy. Between 90 and 105, there's 2. And then there's the Great Pyramid of Cheops way over there between 135 and 150 way at the end. Now we want the ones that's in the middle. So you sort of have to count the number here. This was 2 and 3, and what do we say? This was 12 in here, and then 4, and then 1, and then 2, and then 1. If you add all those up, we get 5, and 16 is 21, 22, 23, 24, 25. So what we want is the 12th one from the edge. So just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That was this batch in here. Between 45 and 60, that's the median height. And so you have to look at the choices. Choice A is not between 45 and 60, that's out. Choice B is between 45 and 60, the correct answer is B. C is too large, that's more than 60, and D is too large, that's more than 70. Okay, so choice B. Okay, median, middle. Next one, let's see, 14, 15, and 16 are all looking at the same table. What we'll do is we'll do these 3 problems and then we'll stop this tape and then do another one for the last batch. A survey of 170 randomly selected teenagers, here's our problem. Age 14 through 17 in the US was conducted to gather data on summer employment. The data are shown. Data is plural of datum. So the data are shown in the table below. So obviously kids 16 to 17 more have a summer job than 14 to 15. Do not have a summer job. That would be, you know, the younger kids. More of those do not have a summer job than do. And the total is 107. Okay. So what we want to do is we want to answer these questions about the table. Which of the following is closest to the percent of those surveyed? Now, what's the total number that surveyed? That would be 170 that have a summer job. So have a summer job, that's the 59. So let's see, we'll take 59 and we'll divide it by the total number surveyed, which is 170. And that's that percentage, so 35% choice B. Okay. In 2012, the total population of individuals in the United States who were between 14 and 17 was about 17 million. If the survey results are used to estimate information about summer employment of teenagers across the country, which of the following is the best estimate of the total number of individuals between 16 and 17 in the U.S. who had a summer job? Okay, so what we're going to do is we're going to go to the 16 to 17. It's this middle row in the chart. And notice there's only, between 16 and 17, there was only 81 people. And of those, 39 had a summer job. So let me find that percentage. This is 39 divided by 81, right? So we're just focusing on the people between 16 and 17. So you have to read problem 15. Okay, which of the following is the best estimate of the total number of individuals between 16 and 17 in the United States who had a summer job? This is our percentage. It's about half. Now, of the 17 million, that's going to represent our 170. Right? And what we want to do is we want to figure out the percentage of people in the country that are between 16 and 17. So let's see. In our sample, we had 81 divided by 170. This is the percentage in our sample, and that's about half as well. So about half of our people were between 16 and 17 in the sample, and about half of them, right, the percentages are actually 47% and 48%, about half of them had a summer job, and now we got to go to the whole country. Well, let me pull up a board here. We have 17 million, about half. So 17 million divided by 2, about half of those would be between 16 and 17. Divide that by 2, about half of those would have a summer job. So about 4 1/4, and of those, the closest, that's 4, is choice B. Okay, so we a little overestimated. Remember, these other percentages were 47 and 48%. I sort of rounded them off to 50%. Choice B is the right answer. Okay, 16, last one. Based on the data, how many times more likely is it for a 14-year-old or a 15-year-old not to have a summer job than it is for a 16-year-old or 17-year-old to not have a summer job? Round the answer to the nearest hundredth. Okay, so we have the percentage of these are not having summer jobs. So for not having a summer jobs, 14 to 15, let me clear off my calculator, that's 69 divided by 89. Okay, that's the percentage that does not have a summer job, 14 to 15. And then if we do the same thing with the 16 and 17s, that would be 42 divided by 81. That's 51. Now the question is, how much more is 77.5280 greater than 0.5185? So let's just sort of grab a sheet of paper here. We've got 0.51815185 times some number, x, is supposed to be equal to 0.775288. Okay, so you can just divide here. We're going to take the 0.77528. I'm not going to put all those digits. I'm going to divide that by the 0.51815, and I get that number. Oops. Let's try that again, Joe. 0.77528 divided by the 51815. There we go. Okay, so about 1.5 times as likely, and if you look at the data, 1.50 is the correct answer. Okay, so it's about 1.5 times as likely, rounded to the nearest hundredth. Okay, let me stop the tape here. Now, you might want to notice I've been pulling up this every once in a while. All the answers are on the last page. I've scanned this. It's upside down. We've done these calculator problems. We've gone all the way up to problem 16, right? 14, 15, 16. And of the calculator problems, there's another 15 to go, so 17 through 31. So hopefully this is, again, being helpful. Let me stop this, and we'll do another tape for the last batch.